Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in computer science. In today's session, we will be seeing about the concepts of constructors and destructors in C++ programming. First, we will see about constructors. What is the need for this constructor in a C++ program? Now, we have seen the concept of classes and objects, that they are basically introduced to implement the concept of encapsulation, abstraction and data hiding. So, what is the need for a constructor and what is a constructor in C++? Every time an object is created, we know that memory is allocated to it. So, memory is allocated only during object creation, not during the class creation. Member variables or data members, they are not initialized when we declare a class. As we have seen in the previous sessions, inside a class you can have variables like strings, integers or float values. But if you see, they have not been given any particular value, only the names would have been defined. So, the main purpose of this constructor is to do that initialization function. Member variables within a class cannot be initialized at the time of declaration. So, though you declare a class and you define its body, you give it member functions and you give it variables, the value of the variables cannot be given at the time you declare a class. So, that is a rule in C++. So, that is the reason why we go in for this concept of constructors. So, here is an example. Here we are having a class called CAL. We are having the class body which has 2 variables, one of type integer, name is num1, one of type float, name is num2. And here the values for num1 and num2 have been given in the class declaration, which is invalid. The class body ends here. Both these declarations and initialization of values to these declared variables is invalid. So, this kind of initialization is not allowed inside classes in C++. Then how are we going to give values to these variables? One way is we can get it from the user. The other way is this definition of the constructor. An initialization function that assigns initial values to the variables declared in a program is called the constructor function. This function is invoked as soon as the object is created. See, as we have seen, every class has a data member and member function. When an object is created for a class, memory is allocated. Based on what the memory can be allocated, every object has a copy of the member function and a separate copy of the data member. So, if the data member is going to be an integer, 2 bytes or 4 bytes is going to be allocated. If a character is going to be a member, 1 byte is going to be allocated. So, based on the number and type of variables declared inside a class, when an object is created, the memory is going to be allocated. When the value is given for those data variables, it can be given using this constructor function. When is this constructor function called? See, when there is a function, you have to call it, you have to send a message to it asking it to execute, only then the function will get executed. So, constructor is nothing but a function which performs this task of assigning initial values. So, when is that function called? That function is called when the object is created. So, a constructor is an initialization function defined inside a class which is called when the object for that particular class is created. Every time one class can have even 10 objects, can have any number of objects. So, every time an object is created for a class, the function is called. So, what is the definition of constructors? They are member functions of a class that have the same name as the class name. So, this is the most significant point about constructors. It is different from the other functions declared in a class because it is having the same name as the class name. They are invoked when an instance of the class is nothing but the object. Invoked when an object of that particular class is created. It is used for initialization of the data members or member variables. They do not return values. So, the two main points in which these constructors differ from other normal functions is their name. They have the same name as the class. The second thing is they cannot return any value. They do not have a return type. You do not say void or integer or float before the name of the constructor. You just give the constructor name and the parameters. So, that is the definition of constructors. So, this is an example of how to declare constructors. You have the class keyword called CAL, the body of the class is opened. You have the private access specifier, you are having 2 variables integer and float. You are having the public data, which is nothing but a cal member function. Now, if you see, the CAL is the same as the class name CAL. That is called the constructor function. You are having opening the body of the constructor and you are initializing it with values. Num1 you are saying 0 because it is of integer type, num2 you are giving 0.0 because it is of type float. So, this is the way constructors are declared inside C++, having the same name as the class name. If you see, this particular name cal and this particular name are the same. So, it has the same name as the class name followed by opening and closing brackets, and there is no return type. There is nothing mentioned here, void or integer or float, because they do not have any return value, and you are having the initialization part being done here. Remember, the initialization of all the members is done here. Num1 is also given a value, num2 is also given a value, and the body of the constructor is closed like you close any other normal function. The class is closed with this semicolon. So, this is how you declare constructors in C++. Now, in case there are no constructors declared for a class, the compiler itself creates a default constructor. Default in the sense, when nothing specifically is mentioned, the compiler will take up that particular option. So, how is a default constructor invoked? The instantiation of an object of the class invokes a default constructor. Like the default constructor is not written by the programmer, it is not even visible to the programmer. The compiler itself creates a default constructor and initializes all the member variables and data members that are declared inside that class for that particular object to 0 values. So, this default constructor is called by the compiler when the programmer fails to create a constructor for the class, and it is called like any other normal constructor. Whenever an object is created for a class, the default constructor is called by the compiler. Now, there is a concept called member wise initialization. In certain cases, class constructors are not invoked to initialize a newly defined class object. Now, according to the normal protocol, whenever an object is created, the corresponding constructor is called and the values are initialized. Certain cases, even when an object is created, the particular constructor is not called. That is in situations where you create one object and give it values from another object. You copy the values of one object to another object. Like you see in this example, when one object is used to initialize another object, you do not require an initialization function over there. The main reason for a constructor is to initialize a data with values. When you are using the values from another object, there is no point in calling a constructor separately. Here if you see, you are having cal, which is the name of the class, followed by the object name OB1. So, when this object is created, the constructor will be invoked. Using that object, you are calling some function disp. Next statement, if you see, you are creating another object OB2, class name followed by the object name cal OB2 is equal to OB1. So, according to this assignment operator, whatever values comes to the right of the is equal to sign is assigned to the left of the assignment operator. So, whatever values have been initialized to the object OB1 are simply copied to the object OB2. So, in this case, the constructor value need not be called because the values are initialized in this statement itself. This method creates object 2 as a bit by bit copy of object 1, and that is called member wise initialization. From one member, another member is initialized. So, in this case, you do not need the constructor function at all. Next, you have constructors with parameters. Like constructors simply work like other functions. Like in other functions, you have arguments, isn't it, actual arguments and formal arguments. Like that, in constructors also you have parameters. Only difference between the other functions in this is that there is no return type and the name of the constructor. When variables need to be initialized with user defined values. Now, previously if you have seen, in the constructor, all the variables have to be initialized values in the program itself. Like you give cal opening and closing brackets and you say num is 0 and float to 0.0, that is all. So, those values have to be defined when you are writing the program itself. In certain cases, you may require that when you are executing the program, you want to give the input or the initialization values. In such a case, we go in for constructors with arguments. Whatever the user gives during the execution of the program, that will be copied to the object's data members. So, how does that? How is it done? What is the syntax for that? We will see it using this example program. You are having the header file, you are having the class declaration CAL, you are having the private data member num1, num2 and TOT. So, there are 3 integer variables. you are having the public access specifier, you are having one function, you are having the constructor CAL, which is the same as the class name. This is the same as the class name. So, this is a constructor, it is having two integer variables int and int. This is a constructor declaration. Next, you are having a function called disp, which does not return any value. You are closing the class body. Now, as I said earlier, these two functions are only declared over here, they are not defined. So, member functions inside a class can be declared inside a class, but defined outside the class, or they can be declared and defined within a class. So, when you are going to define its body outside the class, what is the syntax to be followed? Now, here if you see, you are having the name of the class followed by two semicolons, followed by the function name, followed by the function declaration. You are having the opening of the function, and here you are initializing the values. Now, what are the values that are initialized? You are assigning this x value to the first variable, the y value to the second variable, and this TOT you are assigning it to 0. So, this x and y's values are not known during program compilation. These are the two values that will be given by the user later. Whenever during the execution the user gives these values, they will simply be copied to these integer variables. And then you close this first function. Then again the second function, you are using the class name followed by these two semicolons followed by the function name. Here you do not have to mention the return type. It is sufficient if you mention simply the function name, and if any arguments you have to mention it that way. The return type is not required when you define a function outside a class. Here you are summing up, this is just a program to add two numbers. So, you are summing up the two numbers num1 and num2, assigning it to tot variable, and you are displaying the sum. Now, this two semicolons is called scope resolution operator. So, as I mentioned, these two semicolons, they have a technical term called scope resolution operator. So, what is this scope resolution operator? This is used to access member functions and constructors that are defined outside the boundary of the class. Like here we are having only one class, say we are having another class called cal1, cal2, cal3, cal4. How are we going to know which function is defined outside the class? To which class does it belong? So, for us to know that this particular function belongs to this particular class, we use the class name followed by the scope resolution operator followed by the function name followed by the parameters. So, the scope resolution operator is used to link the function with that particular class, and it is the operator which denotes to the compiler that the function is declared inside this class, but its body is given here. So, this makes the program more readable, like the class definition becomes shorter, and wherever you want the program according to your user's need, he can legibly write it away from the class. So, it makes the program more neat. It is denoted by two semicolons, one after the other. So, now we will see how this main function calls these two functions. Every program starts its execution from the main function followed by the opening brace. You are having two variables n1 and n2. You are entering the value for n1 and using the cin operator you are getting the value. You are asking the user to enter the second value for n2. Then here you are calling the function the cal c1 n1 comma n2. Now, as I said, the constructor function is called only when the object is created. The way to create the object is the class name followed by the object name. So, class name followed by the object name. C1 here is the object. As soon as this object is created, the constructor will be called, but the constructor is having two values. So, you have to pass those two values to the constructor. So, this n1 and n2 are the values which you have got from the user. So, say if the user has entered 5 and 10, these two values will be passed on to the constructor. So, 5 and 10 will be going into this x and y, that will be allotted to num1 and num2. So, now num1 is having 5 and num2 is having 10. Then C1 dot disp, which adds the two values and assigns it to tot and displays the value. So, this is how the program is executed. Then finally, you have the output where you are entering the first value 50, the second value 70, and the output is 120. So, this is how constructors are declared, member functions are declared, they are defined outside the class and they are accessed from the main function. Now, we will see about destructors after the break. Welcome back after the break. Before the break, we had seen about constructors, their definition, the concept of member-wise initialization and constructors with parameters and examples program for each. Now, we will be seeing about the destructors in a C++ program. So, from the name constructor, you can identify that it is trying to construct something, that is for newly created variables it gives some value. So, destructor is just the opposite of constructors. When a value is given to a variable, that means memory is allocated to it. A destructor is nothing but for an object which has completed its work in the program, you are releasing the memory that is allotted to it. That is you are destroying the space, you are destroying that object, destroying that value, and you are releasing the memory space that was allocated to it. So, it is complementary to a constructor. When there is a constructor, there should be a destructor, because constructor allocates memory. So, you have to free that memory at some time. This is invoked when any instance of the class ceases to exist. Constructor is invoked whenever you create an instance for a class. Destructor is invoked when a class instance stops existing. Destructor functions deinitialize the objects when they are destroyed. A programmer is relieved of the task of freeing the memory space that is allocated to a variable. So, from this itself you can identify that this is something like the free function in C. In C we have seen a dynamic memory allocation function called free. Malloc, calloc and realloc allocate memory, whereas free releases the memory allotted. So, constructor allocates memory, destructor releases the memory. Constructor allocates when an object is created, destructor deallocates when the object is destroyed. So, they both are complementary to each other. Now, what are the characteristics of these destructors? First, a destructor is automatically invoked when an object goes out of scope. When it goes out of view of the program, out of the need of the program, the destructor is invoked. This also has the same name as the class. It is prefixed with a tilde symbol. I have given the symbol sign also. A class can have only one destructor. This is also different from a constructor. This also does not specify any return value, and this also can be called explicitly. Now, there are certain similarities and certain differences between constructor and destructor. Both have the same name as a class, they do not have return values, but one program can have any number of constructors, but there can be only one destructor in a program. And secondly, destructors are prefixed with a tilde symbol. They are called when an object ceases to exist, and this deinitializes the memory allocated to an object. Now, we will see how these destructors are included in the program. You are having a class called CAL, you are opening the body of the class, you are having two private integer data members N1 and N2, you are having the public keyword and you are having some function. I have just mentioned it using these dots. This is just a skeletal view, and here you are having the destructor declaration. If you see, it is having the same name as the class CAL followed by opening and closing brackets prefixed with a tilde symbol. And here N1 is equal to N2 is equal to 0. This is nothing but the body of the destructor. Normally in destructors you do not mention a body. When the compiler sees the tilde symbol itself, it will immediately understand that it is a destructor, and whatever variable is mentioned, all the variables that are present in the class will be deallocated and the memory will be released. This is just an example, that is whatever value was assigned to N1 and N2, that has been destroyed and they are assigned null values, and then you close the body of the class. So, this is how destructors are declared inside a C++ program. Now, in this case, how can you explicitly call the destructor? Inside the main function, here you create the object cal followed by the object name, and you do whatever operation you want to do using the object name. The same way you access any other member function, you have to access the destructor. Normally, you use the object name followed by the dot operator followed by the function name. Here also the same thing, you use the object name OB1 followed by this dot operator followed by the tilde symbol and the destructor name. So, this will automatically call the destructor and destroy the variables in the object memory that was allocated and release the memory for use by other programs. You close the main function. Generally, this explicit invoking of the destructor is normally not used by programmers who program usual kind of applications. It is only used in advanced programming scenarios where one object immediately after its completion of work in one particular scenario has to be used for another scenario. In that case, you deallocate the memory allocated to it and you use it for another place. Generally, when objects go out of scope, the compiler automatically calls the destructor and releases the memory. But when memory is needs to be used highly efficiently, we have to save that memory space. In that case, programmers invoke the destructor explicitly. Generally, this is not used by new programmers as well as programmers who operate normal applications. Now, life cycle of an object. Now, we have seen about allocation of memory to an object and deallocation of memory that is done to an object. So, when is memory to be allocated? When is memory to be destroyed? For that, we have to know when an object is created, how long does it exist, and when does it actually cease to exist. Most of the time, we do not tell the compiler when an object dies or goes out of scope. It is automatically taken up by the compiler. So, in this program, we have 3 objects. Each object has a different scope. One object is global in nature, one object is local to a function, and one object is local to a particular block of statements. So, how does a compiler identify when each object ceases to exist and when each object starts to exist? So, here you are having this test class, you are opening the class body. So, this is nothing but a constructor because it is having the same name as the class name. You are opening the constructor function, and here you are not having any initialization, you are simply printing one line constructor invoked. Now, this is generally not done in constructors. Constructors have to initialize values. Why I am using this term is, when you see the output, you should be able to identify that the constructor was invoked, because our main aim of giving you this program is to know when the constructor is invoked in a program. So, that is why in constructor and destructor I have used the terms like this: constructors invoked, destructors invoked, so that you will know when an object starts to exist and when it ceases to exist. So, in this constructor function I am displaying to the user that the constructor has been invoked. I am closing the constructor function. Then here I am declaring the destructor tilde symbol, again the same name as the class test. Inside that I am printing the statement destructor invoked. I am closing the destructor function and I am closing the class. So, if you see in this class function, I am having only 2 functions, class test. One is constructor and one is the destructor. I am not doing any other operation. So, in this you will be able to identify when the constructor is invoked and when the destructor is invoked. Now, always the compiler starts executing the program or compiling the program only from the main function. So, after it sees that #include iostream.h, it will immediately search for the main function. So, if you see here the class is ending, here I am creating one object. Test is the name of the class followed by the object name. So, test is the name of the class followed by the object name. So, the first object that I am creating is OB1. But how does the compiler identify it? After iostream.h, compiler will come to this main function. It will search whether there is any data between the class ending and the beginning of the main function. So, when it sees this test OB1, it will identify that it is outside the class, because the class is ended over here. The class is already ended here, main is starting only over here. So, this object that is created is in between the class and the main function. So, it will assign a global scope to that particular object. Global scope, in the sense it is like a global variable. We have seen what is a global variable, something that is available throughout the entire program. So, the compiler will assign global scope to this OB1 object. That means this object will continue to exist till the program completes its execution. So, the starting of the constructor is here. So, the constructor is invoked whenever an object is created. So, when this object is created by the user and the compiler sees this particular statement in the program, it will identify that it has to call the constructor. Next, it will go to the main function, it will display main begins. Then again another object is created, this is having the function scope. Then some operations are done, then cout in a, this is just some section of the program. Again another object is created which is having the block scope, that is the scope of this particular object is only in between these 2 statements. Then you are closing that function, you are closing the main function and you are closing the entire program. Now, how is the output seen for this particular program? Now, the first time you have the function constructor invoked. So, this constructor is invoked for this test OB1. So, when this test OB1 object is created, it prints this particular data constructor invoked. The next statement is main begins, after that again constructor invoked. So, what happens when main begins? How is this main beginning coming as the next output? After this first particular object is created, the compiler enters the main function and it displays this main begins. Then it immediately moves to the next statement, which is nothing but creation of the second object. So, when the second object is created, again the constructor is invoked. That is what is displayed as the next output, constructor invoked. After this constructor invoked, again it will move to the inner part of the program, inner section starts. Again another test OB3, that is the creation of another object. So, whenever an object is created, the constructor will automatically be invoked. So, again a constructor invoked statement followed by the inner section ends. So, inner section starts, again a constructor invoked and again the inner section ends. So, if you see that third constructor invoked is for this OB3. The scope of this OB3 ends with this particular brace. So, as soon as this particular brace is encountered by the compiler, it will call the destructor. So, after this inner section ends, immediately it will display destructor invoked, because that object OB3 ceases to exist over there. So, we will see how that takes place. After inner section ends, destructor invoked. This is for test OB3. Then you will have the function main ends, because that is the next statement seen by the compiler. So, this test OB2 scope closes with the main function. So, when it sees that the main function gets over, immediately the next destructor invoked will be displayed. Destructor invoked will be displayed again. And finally, when the program ends, the destructor invoked for the first object OB1. So, here if you see, whenever the object is created, the constructor statement is invoked, and then the program proceeds as usual through the normal function. And whenever the brace is the most important part of this entire program. Based on the closing brace and the opening brace only, the life cycle of an object is determined. If an object is having a global scope, it is available during the entire program. If it is inside the main function, when the main function ends, the object ceases to exist. If it is inside a block of statements like a if loop or a for loop or a while loop, once the loop gets over, its life ceases to exist. So, according to that only these constructor invoked, main begins and inner section starts, and all these statements have been displayed. So, this is how the life cycle of an object is determined by the compiler. So, that is the reason when we indicate the body of the looping statements, body of the main function, body of the class, it is highly essential that we are extremely careful, because when we use the constructor and destructor function, they allocate and deallocate memory accordingly. If we misuse the brace, memory will be deallocated when we actually require the memory. So, we have to be careful that we denote the life cycle of an object properly to the compiler. So, I had told about the global scope, function scope and block scope. This we have already seen in the C language. Scope defines the context of the variable, that is where it may be accessed, where it is actually alive. Three types of scope exist in C++. One is the file scope, local scope and class scope. So, file scope is nothing but when we are using the file systems in C. You create one C file, inside that whatever variables you are using, only as long as that file is open you can access it. Once the file is closed, its scope is gone. Similarly, local scope is local to a particular function or to a block of statements. Class scope is as long as the class is existing, the variables and members will have their scope. Once a class is closed and not in execution, not in use, the class variables will be losing their memory. So, these are the three types of scopes defined in C++. So, in today's session we have seen about constructors, destructors, the life cycle of an object and the scope of variables. So, the questions that could possibly come in this session are: the need for constructors is because we have to initialize values to data members. Destructors deallocate memory and they are called explicitly. Use of scope resolution operators to access functions that are defined outside the class, life cycle of an object and scope of variables. So, in today's session we have seen about the existence of an object and how they are accessed using constructors and destructors. We will see about the inheritance, template handling and other advanced techniques in the next session. Thank you.